Hi, this is Zoe and Alice's math video, and we're doing foiling and radicals. We have 4 examples to show you today. I hope you like it.
Okay, first we're going to do foiling. And foiling is used to multiply 2 binomials. And for the first example, we have 2x plus 5 times 4 plus 2x. Okay, so first, the f. We're going to do 2x times 4 right here to get 8x. And then the O stands for outer. And then we're going to do 2x times 2x to get 4x squared. Then the I for inner. 5 times 4 to get 20, and then L for last, and then we're going to do 2 times 2x to get 10x. And then once we have this, we're going to combine like terms, which is 8 and 10, to get 18x. So our final answer would be 4x squared plus 18x plus 20. Go.
Alright, for example 2 of radicals, we have the square root of 20, or radical 20, it's the same thing. Minus 1 radical 5, and the radical 20, it doesn't have a perfect square root, so you do 5 times 4, because one of those numbers has a perfect square, the 4, and then for 5, it doesn't have a perfect square, and nothing you can multiply by has a perfect square, so you just keep that in the radical as 5. So the square root of 4 is 2, and that's perfect square, so you'd keep that on the outside, and then the 5, it still doesn't have a perfect square, so you just keep that on the inside. And then this, it just stays the same all the way down. So you have 2 radical 5 minus 1 radical 5. And you can subtract that 1 from 2 because you can combine them. And so that'd be 1 radical 5 is your final answer.
Okay, for our second example for foiling, we have 2y plus 1 squared. So that's the same thing as 2y plus 1 times 2y plus 1 plus u. And first for the f, stands for first, so we're going to do 2y times 2y to get 4y squared. Then the O for outer to do 2y times 1 to get 2y. Then inner, 1 times 2y to get 2y. Then 1 times 1 to get 1. And then we're going to combine like terms to get 4y here. So our final answer would be 4y squared plus 4y plus 1.
Okay, so this is example 1 of radicals, and it is radical 64m squared n squared, and the square root of 64 is a perfect square, so that'd be 8, and then m squared is a perfect square, so that'd be m, then n squared is also a perfect square, so that would be n. So your final answer is 8mn, because all of these had perfect squares, so you don't have anything left in the radical.
Thanks for watching!